Hello, I'm Dipanshu Mondol. I'm studying physics honors from Calcutta University.
Hello, and I'm Shubham Banerjee. I'm studying Electronics and Communication from Future Institute of Technology.
And we are Team ULTRABOTIC. We have chosen to attend the first problem of the given four, that is to implement blockchain in all sort of banking transactions, such as normal money transaction, cross-border transaction, and loans.
So, we get into our problem and making the application, we first have to know what is blockchain and how it works.
What is blockchain? Blockchain is a ledger that is constantly growing and keeping track of all previous and current transactions, which took place in a secure, immutable, and chronological way. The principal use of a blockchain is acting as a distributed ledger in business applications such as banking, finance, loan, insurance, etc. The objective here is to create a platform for benevolent transactions among the bank, customer, and other stakeholders using any available blockchain platform in the market.
And our approach with this is, with the help of Ethereum blockchain platform, a network is designed for the bank stakeholders where every transaction is registered for every stakeholder of that transaction category. A smart contract is also deployed written in Solidity code for the stakeholders of a given transaction. The platform is visually represented through a web application where a stakeholder would require to enter the category of transaction, his or her role in the transaction, along with his or her credentials, the purpose of the transaction as well, and the application to the stakeholder who is directly opposite to that transaction. And then a notification will be sent to each stakeholder who is in this network, and if the majority sought benevolence in this transaction, then the transaction will be made successfully and a block will be mined and added to the blockchain.
We are implementing blockchain in such a way that it can control the entire banking system and paperless transactions without any centralized body. The environment we are required to make must be able to do the following tasks. In case of normal transactions, first initiate payment request. After that, validation of the amount that to be transferred. Block is then mined and added to the chain, and at the end, reward amount is transferred to the miner. And in case of loan transaction, quite similarly as a money transaction, the loan requests are initiated, and then loan is approved and validated, and then payment of the loan is done, and then at the end, the block is mined and amount is transferred to the miner.
So now let us show how this blockchain is working in the first place. So for that we have created our own blockchain network and our own currency. We will show how these blocks are getting mined and added to the blockchain along with some brief explanations. So let's begin.
Before digging right into the code, let's talk about the prerequisites. So before getting to the code, we need two libraries here. One is Crypto.js and one is Elliptic. So before that, let me make sure one thing, the whole code is developed using JavaScript. So make sure you have JavaScript installed in your computer. So after that, just set up your Visual Studio Code and go to terminal and type in npm init. So what npm init will do, it will install this package log.json file in your current directory. What this package log.json file is, it will install all the dependencies related to this code. Like here you can see crypto.js is added to this dependency, elliptic is also added to this dependency. So how to install this crypto.js and elliptic, let us just now see. So for that you have to say npm I space hyphen hyphen save and followed by the name of the library like crypto.js and press enter, or if you want to install elliptic you just say elliptic and press enter. So after installing everything, you can see they are appearing here in crypto.js and elliptic appearing in the node modules folder, and this is exactly how much you need to know before getting to the code. So after knowing all the prerequisites, let's dig a little deep into the code. So let us see all the classes and all the functions which I have defined here. So first of all, we have this transaction class. So what this transaction class is having a constructor which is having a from address, true address and amount. So what this constructor or this transaction block will do is create a mini block of transaction where it will store from address, to address and the amount which will be transferred to the address. So this is the main function of this transaction class. Then calculate hash function, which is using SHA-256 method, which is included in this crypto.js module. So how this is actually working, you can go through Google and see the algorithm. So it is not in the scope of this video. So it is generating a hash of this transaction block. So then what is the signed transactions? I will get to it a little bit. I will get to it a bit later. Then there is a function called isValid. What this function is doing actually is validating if the blocks that are being added to the blockchain is valid or not. So how can it validate the blocks? Like we all know, the structure of the blockchain is like as follows. Like if the current block is having a hash value, then the previous hash section of this block will have the hash value of that previous block. So it will have a continuation. Like suppose block number A will be having the hash of block number block number B will be having the block of block number A, then followed by block number C would be having the hash of block number B. So this is how the continuation works, and if there is a little tampering happening with this block, then this isValid method will return false. So this is isValid method. Then coming to the class block. So what this block class is doing, our block consists of timestamp, transaction, previous hash and another value nonce. So what is nonce? Except nonce, every other value is pretty much self-explanatory. Like timestamp means when the block is created, the transaction mean the previous transaction block which was created over here. Then comes the previous hash. So previous hash is the hash value of the previous block, and the current hash is this calculate hash function which I have shown here. So what is this nonce value? So there is a concept of proof of work which is implemented in our code. So proof of work means that there has to be some amount of time for mining a particular block to validate that if the block is correct or not. So to increase the amount of time or complexity, every miner has to do a complex mathematical calculation. So in our case, in our code, the calculation is that every hash value which is to be generated must have difficulty of certain sort. Like here you can see mine block has a parameter called difficulty. So what this difficulty actually signifies is, let's suppose if block is generated and a hash value is generated like A, B, C, D, E, F or something random numbers like this. So our algorithm over here works as such that a block or hash value will be accepted if the number of difficulties which is to be given as a parameter, that same amount of zeros should be in the start of the hash value. Like if difficulty is given 3, then the hash value should have 3 zeros at its beginning, like 1, 2, 3. So until and unless a hash like this is generated, it will recalculate the hash again and again and again. So now let's just think for a moment that this timestamp, this transaction, previous hash, these values cannot be changed. So there has to be minimal amount of change so that the hash values that are to be generated and having the exact number of zeros in the beginning. So we have to change something, right? So that is why we are using this nonce variable, and we are here incrementing it until and unless the exact number of zeros which is to be given by the user, like 3 zeros over here, let's suppose for the example. So that amount of zeros will be calculated and then added to the beginning of the hash value. So that is the proof of work concept that is also implemented over here. So now going on, here you can see a class called blockchain. So here you can see the difficulty is given 3. So as I mentioned, it has to be the hash has to be generated in such way that it must have 3 zeros in the beginning. So you can increase or decrease this difficulty value as per your requirement, because the more the value is, the more time it will take to generate and mine a block. So that's why the moderate level for our example purposes is 3. So what is now this pending transaction? So as I mentioned that it takes some times to mining a block. So what will happen if someone else trying to do a transaction at the same time? So will the blockchain will reject the transaction? No. What it will do is, while the block is getting mined, it will take the transaction which is requested and it will push it to the pending transaction array. So here you can see it is a null array, and after the block which is currently being mined, after that is mined completely and all the mining rewards and everything is sent to the users, then the next block, the next transaction which is in this array will be evaluated, and the same process will go on and on. So now another concept comes, what is this mining reward? So in blockchain we have to know two basic things, that there are a normal transaction and there are a mining reward. So let's suppose user 1 is sending some amount to user 2. So let's suppose user 1 is sending some amount to user 2. So now let's suppose that amount is 100. So what will happen in the background is, the block will be mined, but who will mine this block actually? Not user 1, not user 2. There will be a completely separate machine which is called a mining machine, which has a tremendous hardware configurations and which is very capable of doing these computations very quickly. So there is practically a race going on for mining these blocks. Why is this race going on? Because if someone, suppose A, B and C, these three are actually waiting for mining this block, and mining and adding this block to the blockchain, and after adding this block, the transaction of 100 amount from 1 to 2 will be completed. So A is trying, B is trying and C is trying. So everyone is trying. Whoever does the mathematical calculation which I have just mentioned most quickly, he will win, and that block will be added to the blockchain. And what in terms of return they will get? So here we are declaring the mining reward as 100. So after the user, suppose let's say A, completes the mining first and added the block to the blockchain, then the amount 100 will be transferred to the user A as mining reward, and this 100 amount will also be transferred from user 1 to user 2. So this is the function how our blockchain works. So this is the part where the class blockchain and constructor blockchain working. So now what is Genesis block? So as I have also mentioned earlier, that a block containing the previous hash value of the previous block. So let's suppose if the block which is being generated is the first block of the blockchain, so there is no block present in the previously, so how can it have the previous hash value? That's why that block is called the Genesis block. So we are actually hard coding and making these Genesis blocks ourselves, where 0 is the previous hash value, and we are making the name here Genesis block, and address over here, timestamp over here is given by us. So this is the way we are creating Genesis block. Now mine pending transaction, as I have also discussed earlier just now, that this is the process how the blocks which were being added in this pending transaction array is getting fetched one by one and getting fetched one by one and evaluating and completing the transaction. So this is the mine pending transaction method. So now here it is add transaction. So what this add transaction doing is, it is actually checking that if the transaction from address and transaction to address, if they're equal. Suppose someone is trying over here sending 1 to 1, which means what? I am sending some amount to myself, so it is obviously not possible. So that's why we are throwing an error. The transaction must have from and to address. So after that we are checking is valid method. As I have also mentioned earlier, that is valid method will do what? It will return true or false with respect to if the transaction block which is created is valid or not. So that's how we are checking that if transaction is valid or not. So this is how this add transaction method is working. Now is chain valid? So what is chain valid is is also similar to is valid method. Here we are actually checking if the blockchain, the total blockchain is valid or not. So the process is exactly the same, like each block having the previous hash value, which is in case our blockchain the hash value of the previous block. So which means what? If B is having a previous hash as, let's suppose, 123, which means the immediate previous block, let's suppose A, having the current hash as 123. So this is checking one by one if the current hash, current block and previous block, the hash values of each block is similar or not. If someone tries to tamper with a minor amount of data, the hash values will change and this function will return false. So now lastly, this get balance address. So get balance address is doing what? It is actually, let's suppose, go over here and let us continue with our example. Let's suppose one is having 100 and two is having 0, and one is transferring 10 amount to 2. So that's mean what? The value of 1 will reduce to 90 and the value of 2 will get to 10. So that is exactly what is happening over in this block, get balance address block or method. So this is the block.js file, and we have two more files which will be discussed later on this video. Before running and actually seeing the output of this code, there is a little bit issue with our code which has to be solved. So what is that issue? In the blockchain so far, there is an issue that anyone can make use of any coins that doesn't belong to them. So we have to resolve this issue. So we have used the concept of over here, the concept of private and public key. Using this concept, the sender signs the transaction with the private key which is exclusive to him, and only the user who is sending has the private key, and the receiver has to decrypt and get the balance using the public key of the sender. So let's see how it works. So for that, here we are using this elliptic method, the elliptic module. So we are generating public key and private key. So we are generating in the form of hex. So this bit of code is written in keygenerator.js file, and over here, which I have skipped a little bit earlier, that is this part, like sign transaction. So I have skipped this part. So now coming to this part. So what is happening here? So we are actually signing the transaction with the private key of the sender. So how it works actually is, here constant sig is equal to sign key dot sign. So what this sign method is doing, it takes the input has the private key of the sender and it signs the transaction where it is the transaction block with the private key, and when the value is transferred, let's suppose a user 1 is sending to user 2. So how this sign method or the sign transaction method will work, let us just understand over here. So the one has a private key and a public key. The private key is exclusive to the user 1 and nobody else knows the private key, and the public key is available to everyone in this blockchain. So what this transaction of 10 will do, user 1 will sign this transaction 10 with the private key. So the private key is signed and then this is sent to user 2. Let's write it over here. And how this user 2 can get this amount? He has to decrypt it using the public key which user 1 has. So user 2 decrypts it using the public key, and then it will get the amount 10, which will be added to user 2. So that's how it works. So now a question may arise that how this public key and the private keys are actually generated. So over here in this elliptic library, there are some methods or there are some algorithms going in background which is actually generating a version of hex key. One is public key and one is private key. So get private and get public, these are two methods which are defined in this elliptic library. So now let us just run this code. Let's see. over here we are running this code, and let's see what the output is. So here we can clearly see the balance of, so here it says that starting miner means what? The mining is started, the block is successfully mined. So now the current balance of the miner is minus 100. So which means what? The amount 100, so it first had zero amount. So over here I have to change a little bit things to make it a bit more clear, but you can understand over here that firstly the user Shubham had zero, so which is actually sending 100 amount to user, let's suppose 2. So that's why it's showing that user Shubham having minus 100 over here. So if you look at the chain closely, here you can see this is the genesis block. It is the hard-coded value which we have put in over here, like genesis block, the date, the previous hash is 0, as you can see no other block is previous to that, and the nonce is 0 because we don't have to calculate the nonce actually for the genesis block. So after that, here coming to the transaction block. So this is transaction block where we are sending, as mentioned, that 100 is sending from Shubham. So that's why, because Shubham usually had 0 in his account, so that's why he is having right now minus 100. So 100 is transferring to address 2, and this is from address. This from address is of this user Shubham, and this is the signature part which I have mentioned right now. So this one is the private key of user Shubham, which is the center over here. So now this block is mined, and this block is having difficulty level 3, which means what? The hash value which is to be generated having over here, let's look a bit closely, 3 zeros at the beginning. So that's why this difficulty level is 3. So here you can see the block is mined. Over here the nonce value is getting incremented one by one, and after reaching 3766, all the first three values are getting 0 0 and 0. So that's how all this code is working. And here also we have defined the mining reward, we can see as 100, as I have mentioned earlier, I guess. So what it is, yes, the mining reward is 100. So that's why after the block is mined, the miner is also getting here 100. So this part of transaction, you can see the from address is null. So there can be a question why the mining transaction is having the from address null, because getting to this example, let's suppose A is mining the block and A is getting the mining reward. So there is no necessity for A to know who is actually sending him the reward. He is actually all he is cared about is how much money he is getting. He doesn't care who is sending him the money or where it is coming from. All he cares is the mining reward. So that's why he doesn't have to know who is sending the value. All he has to provide is the address of himself, like to address where the amount will be transferred, and the amount how much will be transferred will be predefined by the code over here. Let's for our example purpose it is 100, so that's why 100 is transferred to this address, and from where it is getting transferred we don't have to know it, and the mining reward is 100. So that is how the code is working. We can see completely functioning blockchain with proof of work concept, the signing key concept, and all the security features which a blockchain can have. So thank you.
So here we have written the front-end code in HTML, CSS and PHP. This is our login page code, and as you can see it's in HTML and in PHP. There is a transaction page written here, processor 2 PHP, and there is a process 3 PHP, and the middle page. So now in order to show that in our browser, we need to turn on the Apache, MySQL and Tomcat servers from XAMPP control panel. Now here is our login page. So in this login page we have two text fields and a submit button, and in this text field we have to insert the account number and account password, for which we have created a database with user table. As you can see we have two entries here, username and password. Now if I insert the username, this, and a password, and we submit it, Here we go. We are in the middle panel. Now from here, if we want to go to do some normal transaction, we select this and we submit, and here we are in the transaction page. So here, if we want to transfer, if user uh, if we want to transfer to user 1 from user 2, say 100 amount, and we submit it, see, here we are in the transaction complete page where it's written 100 amount is transferred to user 1 from user 2. Now if you want to go to home page, we are calling this as home page as we don't have the perfect page system here. And if you want to make a loan amount, we go here, and here is this form where who wants the loan, let's say user 2, what kind of loan, let's say home loan, and amount, let's say 1000, and we submit it. And here again we are in the transaction complete page where 1000 amount is loaned to user 2 from X bank. Now we can log out from here and we are returned to this previous page. So now how is this actually working? Let's see. So I want to make a loan transaction. Here I am. I want to send the loan, let's say to user 1 for, let's say, car loan, and that should be, let's say, 20,000. Now when I press the submit button, all these entries are getting into a database as a tuple, and that tuple is forming a report, which report is then being sent to all the stakeholders. And if the stakeholders, all of them, validate, which is now one validation, if they validate it, then and only then the transaction is going to happen. See, if I press submit button, the transaction is being completed.
We have actually seen so far how the front end is actually working and how it looks. So this is the main backbone of the front end, which is the Solidity code. And let's see how it works. So before getting into it, we have to know it is running in the Ethereum blockchain network, and we are using Remix IDE for Solidity, and the version of Solidity which we are using is 0.4.25. So the environment we are going to use to run this Solidity code is Web3 provider. So before connecting to Web3 provider and connecting our front end to this back end, we have to start one thing, that is go to command prompt and start test RPC. So what this will do is basically start a server, and if we just go to Web3 provider and at this host, or rather at this port, a server is connected over here, you can see, and over here you can see listening at 8545 port. And if we just connect it and press OK, here you can see it is connected. So all the get balance and all the functions are showing over here. That means that our Solidity code is connected with the RPC server. So this RPC server is basically nothing, just helping us to connect the front end with the back end. So let's in brief get to know a bit about the Solidity code. So it basically had three stakeholders, like three users: first stakeholder, second stakeholder, third stakeholder, and we are defining all the balances of the stakeholders initially to 0 0 0. So this is the constructor, and this is the syntax is kind of similar to Java. So there has no issues to actually understanding what is written over here. So first stakeholder, second stakeholder, and third stakeholder all initially having 0. And then what are these things? Government, bank, investor 1, investor 2. So as stated in our problem statement, if someone, let's suppose, taking a loan, then the loan has to be approved by this entities like government, bank, investor 1, investor 2. So the main problem statement were given, like if let's suppose someone is, like suppose A is taking a car loan. So for car loan, the validation must be from users like the bank itself, the government, the dealer from which the car is being taken, and if it's an education loan, then the validation needs to be taken that if the institute where the student is studying is true or not. The government also pays a validation loan over education loans rather. So this means what? In each bit of loan, the validation or the entities which are validating is different. So for the demonstration purpose over here, we are taking specific validation entities like government, bank, investor, and investor two. So what is this bank balance? Bank balance is a fixed amount of balance which the bank is currently having, which is this large value. This is to demonstrate like if suppose user one is taking 10,000 amounts of loan. So which means what? The bank obviously has to have more than 10,000 coins in its account or in its pocket. So that is how the bank can give the money to the user one. So that's why we are initializing it with a big amount. And here what this 1111 means is that all the users, or rather all the entities which are validating, actually agreeing to the loan purpose. So if all the values are 1, then the loan or the transaction will be approved. So now this get function will do what? It will return, it will take a parameter as 2, and it will return the amount or the balance which is having in that 2 address. Like if we are getting we are going to get the balance of user number 1, we have to input user number 1 over here, and it will return the user number 1 balance. Then the validate, this is the function which I was talking about. This validate function has to work like this, like if all of them is getting 1, then it will return 1, and if any of the entities is getting value 0, then it will return 0 directly. So now lastly, the not last actually, transaction method, what is doing, it is taking balance to and from. So it is quite self-explanatory, like we are first checking that if the to address is 1 and from address is 2, that means what? From 1 it is transferring to 2. So that's why we are incrementing the balance of first stakeholder and decrementing the same amount of balance from second. And this is happening is just if else case. And lastly, there is a loan function which is taking the balance and the 2. So which means what? The amount that is to be transferred to that user and the amount which is to be transferred. So here first we are checking that if the stakeholders or the entities are actually agreeing over here or not. So if it returns 0, then the loan will be not validated and it will fail. And if it returns 1, over here you can see that we are checking if it's 1, then the loan will be successful and the bank balance will be deducted and the first stakeholder balance would be added over here. So that's how basically the code. Finally, running this Solidity code, over here we have this buttons which represents the functions we have written over here. Like the get function returns what I have mentioned earlier, that the amount balance that is having the user which is being I mean which is given over here. Like if 1 is given and we press get, then it shows user 1 is having 100. If we press 2, then user 2 is having 0. So let's just transfer some amount from user 1 to user 2. So this transaction, let's go over here and see. First we have to pass the balance. So let's suppose 10 has to be passed to user 2 from user 1. So transaction happening, and over here you can see user 2 having 10, and so quite obviously user 1 will be having 90. So what this validate method is actually doing, so just because all the loan entities having values 1, that's why it's showing 1. So which means if someone, let's suppose first let's just check how much balance does the 3 having. Here it is having 0. So let's suppose 3 wants some loan like 1003, and just because the validate value is 1, so loan will be validated, and if I just press loan and then get, then it will have here 1000. So just because the validate returns 1, that's why the loan is being validated and the loan amount is transferred. One last thing over here you can see if I just pull it up, with each transaction there is some values associated with it, like the transaction hash, the from to the transaction cost. This transaction cost, this gas value means what? This gas value means some virtual currency is actually spending because we have to complete this transaction. So that's why this is the gas value, and this is a hash value and input, and all these parameters is quite self-explanatory. Like if you have seen the previous part of the video, you can clearly understand what this transaction hash from to or what these values are. So that is pretty much it for our project submission. Thank you for watching.